stream, the people on the stream. Please welcome our next speaker, Paul Schenkeveld, who is an independent BSD consultant from the Netherlands, and he's going to tell us about what's new in FreeBSD 10. Please.
Thank you. I've been doing this before, FreeBSD 9, FreeBSD 8, and I don't know how many times. I thought we'll do it a little bit different today. Let's turn this in a workshop. The release notes have been mailed around just a couple of days unannounced, and they're on the website. I assume you all have a mobile device, so you just pick your device, go to the release notes, read them, and then the last 10 minutes we'll do a little pop quiz. What about that? No? Okay, FreeBSD release 10 was just released a couple of days ago. I want to give you a little overview of the FreeBSD release engineering model. The little picture here shows the way that versions are derived from the FreeBSD repository. The slant line here is what we call the head release or trunk. That's where most of the development takes place, and then every now and then, currently at a pace of about once every 2 years, we get a new major release. Those are the horizontal lines, and every release starts with a 0.0, which we consider an early adopters release. That means please try it as much as you can with the stuff that you use on a daily basis. But keep in mind it's new material. Things can go wrong in unexpected ways because, well, developers do a lot of testing, but don't know your exact workload. Then the following releases, the 0.1, 3, 4, and so on, are generally considered stable releases. And when every release is cut from the tree, we get another small branch, and they're depicted by the little arrows pointing upwards. That's what we call the security branches. So after a release comes out, say 10.0, then this little branch pointing upwards will only get security fixes or very important bug fixes, stuff that really affects almost everybody, like if they find a last-minute glitch in the SATA drivers, for instance, or in the networking layer. But generally speaking, on these release branches, things are very stable and do not change that much anymore. Apart from all these releases, the stuff that you can grab as ISO images these days and install, there are also nightly snapshot builds. They are for, well, developers, people who are interested in early testing, but they get no support, and it's just to get a preview of what's being worked on. One thing very important in the FreeBSD release model is that within a major release, one of the horizontal lines, the kernel application programming interface, but also the kernel application binary interface remains unchanged. That means that you've written a piece of software for version x.y, then that piece of software, even if it's a device driver, should work out of the box with all the version numbers that start with x. So x.0 up to the last one, x dot whatever. That's not the same in other operating systems per se, but FreeBSD finds this a very important feature. The support that the FreeBSD project provides for the operating system and for the releases depends on whether a certain release is tagged as either the early adopter, the normal or extended support releases. Well, early adopter releases are the 0.0 releases that I just explained. They only get 6 months of support. The other ones, I've divided them in black and yellow version numbers. The black numbers are normal releases. They will be supported at least for 12 months or at least until a newer stable release has been out for 3 months. So you get some time to upgrade to a newer release before support for your old release stops. And the red ones are called extended support releases. They even get supported at least 24 months after the release date. So if you're running FreeBSD in a production environment and you do not want to upgrade your system once per year or even more frequently, then you can just hop from the extended support releases. So for instance, you had a machine running on 8.1, then you can jump to 8.3 or 8.4, you can jump to 9.1, and most probably 10.1 will be another extended support release. So completely depending on what you're running your FreeBSD on, where you're using it for. Is it for personal usage? Is it for playing around? Or is it for serious business? You can choose the pace at which you upgrade your system. Right, FreeBSD 10. 10 is a number, and we seem to have some problem with numbers. We keep making mistakes over and over again. Y2K. Who doesn't know what the Y2K problem was? Of course. 9th of September 2001, we had another similar problem. Who? You. Anyone else? Give a little hint. It was at 1:46:40 UTC in the night. No? The Unix internal clock reached the value of 1 billion. That should not matter because it's a 32-bit binary value, but still there are applications that handle Unix time converted to a decimal string. And that string grows 1 digit larger and has caused some problems. Y2K38. Whoa. Hands, please. A few more, of course. On 19th of January 2038, 3:14:08 UTC. The Unix time will wrap around the short integer or the 32-bit integer in which we store it currently. That's even more scary because if you add 1 second, well, exactly at this time, it becomes a negative value. Unix time is a signed int. What does it have to do with FreeBSD 10? Well, 10 is less than 9 if you do a string comparison. And while working on production of FreeBSD 10 release, lots of scripts broke because they did a string comparison compare if the version is less than a certain version behave like this and otherwise behave like that, which worked fine for FreeBSD 2, 3, 4, 5, 6 and so on, but not for 10 anymore. There have been some discussions on the mailing list, even people suggesting to continue with the number 9 or to start with letters or whatever work around. Fortunately, the wise people have won and said, no, 9 plus 1 is 10. If our software is broken, if our scripts are broken, we just fix them. And we don't work around it because that's easier. Okay, so as I just said, we have a major release coming out roughly every once in 2 years. So what's our next problem, our next challenge? 2194, FreeBSD 99, FreeBSD 100. Brace yourself. Okay, enough of the light stuff. Let's go on with the serious stuff, what's new in FreeBSD. As always, and I'll just summarize here and not go into that, there's lots of security and bug fixes. There's new device drivers for new hardware. There are enhancements to existing drivers, enhancements in the network stack. The same goes for libraries and commands, utilities. Unfortunately, also a few new bugs will be introduced, I'm sure. Please, all of you, help the project. Send in your problem reports using SendPR. And if you know what the problem is and how to fix it, suggest a fix as well. It's a project which is mostly run by volunteers. And I think, I'm a user, I'm not one of the developers, but I think that the project is doing an awesome job here. But every bit of help that can be provided is very welcome. Well, with big numbers, I consider 10 a big number compared to the 9 numbers before. We also have big changes. FreeBSD 10 is really full of new stuff. One thing that's been going on for several releases, but FreeBSD 10 makes a big step here, is getting rid of GNU licensed stuff. Why is that? Well, the GPL license, it's perceived by some people as the most free license, but in fact it has all kinds of strings attached. And in GPL version 3, that has been around for a couple of years now, one of the new strings attached is that if you use development tools with a GPL version 3 license, you may have to release the software that you've built using those tools under the same GPL license. So up to FreeBSD 9 we were stuck with old versions of the GCC compiler and the binary utils that are needed to compile our system and all the software that we run on it, because in the base system we could not upgrade to a newer version of the GCC compiler and the binary utilities that carry this GPL version 3 license. Then you can do several things. You can just stick with whatever is the last GPL version 2 compiler, which still allows you to compile FreeBSD and release it under a BSD license. Or you can look at what has been changed after that in the GCC compiler and port that yourself. Well, the first one means standing still, and standing still is not a good thing in this industry. The second means a lot of effort. So the most logical solution was find something to replace GCC and all the GNU licensed tools. We've been working on that for several releases, in FreeBSD 9 we already saw that Clang or CLang, whatever you want to pronounce it, was the new C compiler in the base system. In FreeBSD 10 it's the only compiler that comes with base. GCC is completely cut out now. Also the libraries, most notably the lib standard C++ library, was released under the GNU license and was sticky, considered sticky. A lot of work has gone into replacing that with the lib C++ from the LLVM project. The LLVM project is the project that also created CLang. Then in FreeBSD 10 AR, the archive manager, RenLib and some other tools have been replaced by tools that are BSD licensed, or at least have a more relaxed license. On the non-development side, we already had libarchive, which is a library that can read and write all kinds of archives like tar and CPIO and I believe zip and some others. And utilities like tar and CPIO have been re-implemented on top of that library, completely BSD licensed, and for a while they have been both in the system, the old GNU licensed version and the new BSD licensed version. And in the beginning the GNU licensed version was the preferred one, but if you wanted you could try the new one. We flipped that, I think, in FreeBSD 9, and the BSD ones became the preferred ones, but the GNU ones were still available, and now it's just the BSD ones. Well, the GNU ones, of course, are still available to port, but not in the base system anymore. And well, CPIO is one, sort, the two calculators, BC and DC. Find was already replaced some time ago, but our new find had fewer features than the GNU finds that we used to have before, and some of the most wanted features have been carried over now. They have been re-implemented in a clean room into our BSD licensed find. What does this all give you? Well, as a user you would say not much. We had all these tools, we have these tools again, but they now have a different source and maybe even different bugs and a different license, but why would I care? Well, I think it's underestimated what would happen to the project if we hadn't done all this. The FreeBSD project would just stall and die. Right. Who has seen this bugs section in one of the FreeBSD manual pages, and who can tell which manual page contains it? Yeah. FreeBSD 1, for those who have been around for a while, was based on software that was still partly copyrighted by AT&T, later Novell, and there have been some court cases about that, and the ruling was that under the supervision of developers of the other party, the FreeBSD project would have to take out all the offended code and start from scratch with a code base that's completely free, completely BSD licensed, and that was FreeBSD 2.0. At that time we also needed a new installer, and one of our founders, Jordan Hubbard, he quickly wrote a new installer and wrote the manual page for it, and wrote in this manual page, well, it's a quick hack, we have to replace it quickly. 1993, I think. Well, in FreeBSD 9 we already got well, this is the manual page, of course. Yeah, one of the problems is it's completely written in C. It's not even that bad inside. It's even in some places quite ingenious. But adding new stuff is not that easy. So sysinstall has always lagged behind on other developments in the operating system, like new file systems and other nice stuff. We got a new installer called BSD install in FreeBSD 9, but sysinstall was still there. FreeBSD 10 does not have sysinstall anymore, at least not by default. You can still compile it if you want to, but it's not there by default anymore. Sysinstall did two things. One is installation of the system, and the other thing was the menu where you could set your root password, your time zone, you do your networking, add some users and stuff like that. That's been split off. We now have two separate tools, BSD install for the installation and BSD config for all the post-installation system management stuff, because people want to revisit that and don't need the installation stuff anymore. It's mostly written as shell scripts, and interaction with the user is done using a little program called Dialog. Dialog is just a little tool that gives you a ASCII menu or an input field or a form with input fields. And that's the only part that's not written as a shell script, and everything else is very easy to maintain and extend. Oh yeah, SADE. Who has been using SADE? One, not many. It was a subset of the functionality of the old sysinstall, where you could manipulate your disk partitioning and stuff like that. It was there, it had to be maintained, and very few people knew that it was there and used it. So they're gone. And we got another installer. The same time that in the FreeBSD project people were working on BSD install, some other guy working for a commercial company who does a lot for the FreeBSD project was working on a FreeBSD derived desktop operating system, BSD. I'm sure you've heard about it. And he wrote his own installer, also mostly as shell scripts, very easy to maintain, very nice user interface. There have been lots of discussions, why not merge the two or choose one and let the other one die. Well, there is still a lot of overlap in the two, but they also have their own features that are not present in the other ones. So BSD sysinstall still exists, and as a courtesy it's included in the base operating system too now. So you've got a choice here, and BSD installs what you get when you fire up your ISO image. But if you want the extra functionality which is in PC sysinstall, and someone over there with some blinking ears maybe knows, is it already available in PC sysinstall that you can do a complete configuration offline, store the results and replay that? The replay of a stored set of install options on a remote machine, that's so yeah, it's really, PC sysinstall really has some very nice functionality beyond that of BSD install, but it's not maintained within the project. Okay, the ports people have also been very busy over the last couple of years, and the old tools, PKG add, PKG delete, PKG info, and all the other ones, they're out finally. Most of you will have seen VARDB PKG, which is the repository of all the packages that you've got installed. For every package or port there was a subdirectory with the name and version of the installed software, and that subdirectory contained 4 or more files depending on the port. On the laptop that I use every day, I have something like 1100 or 1200 ports installed, and some other machines even more. That is quite a lot of small files and a lot of inodes, and that makes handling the package repository slow. Things can break very easily, and well, it was a very nice design when we only had a few ports installed, 10, 20 ports on a system in the beginning, but nowadays it just doesn't scale anymore. What did we get in return? A single command called pkg that does all the work, and you just type pkg space install or pkg space list or pkg space delete to work with your installed packages. And the repository has now moved into a little SQLite database. It's one little file. You can make backups quite easily. It can be checked and repaired, and it's just a much better system. Well, the packages are for those who want to do binary installs. If you want to go with the sources, you compile from ports. Also, a lot of things have improved there. Originally, when the port system was invented in FreeBSD, by the way, it's one of the features that really made FreeBSD stand out from other operating systems right from the beginning, and other operating systems have adopted our port system afterwards. But if you had ports where you could, at compile time, make some decisions whether you want feature X in or not, for instance, if you want it with Kerberos or without Kerberos, or with yellow pages or without yellow pages, you did that using make flags on the command line. So you would say -d no Kerberos, or later on changed into -d without Kerberos. A couple of releases ago we got the options framework, where in the makefile of the ports we could just have a list of options that can be switched on and off. And the first thing that make install or just make would do for you, if you had not done it before, is give you a little menu using the same program called dialog that's used by the installer, present you with all the options and the default values and a short explanation. You could go through that menu and change your compile time options very easily, and your answers would be stored in VarDB ports. So next time when you upgrade the same port or you want to recompile for whatever reason, you just get your old answers back. That was a good step in the right direction, but it still lacked a lot of features, and one of the things was constraints. Some options cannot go together. Sometimes options require another one, and in FreeBSD 10 now the ports system has a very nice enhanced version of the menu that knows about these kind of constraints. If you can choose between A and B or A, B and C to build your port, then you can only choose one of them in the menu, and that all works very nicely. Another thing that has happened recently in the ports area is staging. Originally, the port system, when you make and then make install your port, would install it directly onto your live file system. If you then needed a package, you type make package, and it would grab the files it just installed, put them in a big tarball together with some extra configuration files, and that would be your package that you can install somewhere else. And this has gone wrong more than once. Because the port skeleton must know which files to include, it sometimes happens that not all the files that were actually installed ended up in the tarball. that had two problems. One problem is if you remove the port afterwards, you do not remove everything because there's no trace of the files that were installed but not recorded or not registered. The other problem is I now carry over this tarball file to another machine, install it there using pkg add, and I get a complete install minus a few files, which has bitten me several times in the past. The new thing, staging, means that we do not directly install in the live operating system, but instead an empty directory tree is created. The installation goes into that empty directory tree, and the package is created from there and then installed as if it were a binary package. So we know exactly what we are installing, and we cannot just forget one or two files. Or if we forget them, they are also not installed on my live system. So developers will know very quickly that they've goofed up and forgot one of the files. You know, we almost have 25,000 ports now. Right. Not a big thing in FreeBSD 10. There's a lot of work gone into virtualization. First, a few of the smaller ones. We have better support for VMware now. And not from the release notes, but from the quarterly reports, I learned recently that the company behind VMware now also committed to supporting FreeBSD licensed drivers. They ignored us for a long time, but they now want to cooperate, which is great. And they even support the FreeBSD Foundation now financially, which is also great. We now have the virt.io drivers in our generic kernel. virt.io, block, SCSI implement storage drivers in such a way that they work nicely together with hypervisors. We don't need to emulate the hardware anymore. VTNet does the same for networking. And the virt.io balloon is a memory controller device which allows multiple virtual machines on one computer to coexist and use more memory than is physically available. And the balloon driver lets one virtual machine grow and the other shrink when needed. These drivers are originally developed for Linux KVM, but most of the hypervisors nowadays support them. For Xen, we got hardware virtualization support in our standard kernel, so it now also works much better as a DOMU and Xen. But then the big exciting news, and I don't know if any of you have been in my talk here at FOSDEM 1 year ago when we were in the other building. FreeBSD since 1 year has a new, brand new BSD licensed hypervisor called Beehive. Last year I told you guys that it was only 2 weeks before FOSDEM that Beehive was included in HEAD, in the development tree. It's now part of a release. It comes with FreeBSD out of the box. It runs on a generic kernel. You just have to load a few loadable modules and then you're done. It's BSD licensed, as I said. It's very high performance, but it needs a little bit of support from your CPU. It doesn't work on all the CPUs. It needs enhanced page tables and virtual machine exits and VTD, that's the virtual I/O exits. So on NeLM cores, which is like the Xeon starting 2000, 10 or so, and the Core i3, i5, i7s that came afterwards. It usually should work, doesn't work on the low-end Atom machines, but it makes building a hypervisor much easier, and so the Beehive code is much smaller, much easier to understand than the other hypervisors are around, and that's why we could develop it so quickly, and it's already really very stable. Right, there's a lot of new work being done on the Beehive hypervisor. I read something in the quarterly reports that they're now trying to integrate it into some very nice cloud server software. You can read on that in the quarterly report that came out a couple of days ago. But this is going to be our future. This is going to be standards in FreeBSD, and as natural as jails are since FreeBSD 4, Beehive will be starting FreeBSD 10. Right, I mentioned some of the Intel and Intel compatible hardware already. We also used to support Spark processors and PowerPC, and we have even for a while supported Itanium processors. But the big new kid on the block, the one that's getting everyone's attention in the world at the moment, is the line of ARM processors. And there has been a lot of work going into ARM. ARM is a very modular platform, so there are many different ARM processors that all have more or less features, which makes it less easy than supporting a platform like i386 or AMD 64. But we are finally getting at a point that more and more machines are actually supported and work. The Raspberry Pi, which is a very small credit card sized board, I believe it's only $35. It's now supported by FreeBSD 10, and at one of the tables downstairs here in this building I saw a Raspberry Pi with a little sticker on it that runs FreeBSD 10. So this gives access to FreeBSD also for lots of students who play with these little pieces of hardware, and for the industry at large that uses ARM in set-top boxes, entertainment hardware, mobile phones, tablets, and so on. Okay. The networking people have also been very busy. CARP, which is our redundancy protocol, much like VRP, but VRP was apparently licensed by Cisco, so that's why we got CARP from OpenBSD. CARP has been rewritten completely. It's much cleaner now. It supports a lot of new features that were very difficult to implement with the old CARP. One little feature, load balancing, is not present at the moment. I believe it's being worked on, but for doing high availability computing or firewalling, this is very good news. PF, the third generation firewall in FreeBSD after IPFW and IPFilter, which we got from OpenBSD, has suffered for a long time. The OpenBSD people have focused very much on security and security features, but they did not do much in the multiprocessor field. So PF was always very coarsely locked and did not perform well if you have high throughput like 10 gig interfaces on a multi-core computer. The FreeBSD team has been working a lot and got fine-grained locking into PF, and PF now also filters very well at high speeds. So you can do your 10 gig internet connections, filter them with PF, and not worry about your CPU, can it handle or not. IPFW got a little enhancement for differentiated services code points, DSCPs. A new framework called NetMap, which is designed for high performance applications, applications that do a lot of networking, get a lot of packets in, send a lot of packets out. I'm thinking about web servers, I'm thinking about proxy servers. They can do networking with much less copying of packets around in memory. That's the limiting factor nowadays with high-speed networks. And well, on the driver side, many enhancements and additions, but especially also in the 10 gigabit field. Another piece of old code that we have been carrying around ever since the beginning of FreeBSD, that's causing more and more problems for release engineering, is the bind DNS software. Bind named really plays two completely different and usually separate roles. It can be used as a authoritative name server, the one that services FOSDEM.org, for instance. And it can be used as a resolver, so the little name server that all your PCs and mobile phones connect to do the resolution for you. Most machines that you will install only need to have a resolver and don't need a complete authoritative name server. You're not running your own domains on all of your machines. You just must be able to resolve them. So we now have a new resolver in FreeBSD 10, which is called Unbound. It's developed by NLnet Labs in Amsterdam. And it's only a resolver, it's not a complete name server. Therefore it's much smaller, easier to maintain, and hopefully less security problems than a full authoritative name server. Authoritative name servers are a high profile target for denial of service attacks and other mishap on the internet. The resolver is much less visible from the outside and therefore much less interesting for hackers. Bind is still there, but it's moved to port, or Bind has always also been in port. So if you still want to run your own name server for your own domains on the internet, you can do that, but you just have to install DNS/bind 99 or DNS/bind 10 if you're courageous. And the bind suite did not only contain the named server itself, but also a lot of small tools, NS lookup, dig, hosts, and some other ones. We lost them too, but as a bridge between just having Unbound and having everything, there's a new port called the DNS bind tools, which just gives you these little tools like NS lookup and dig. Host, by the way, is still in base, so if you can live with host and you don't need dig, then you don't need the bind tools. But if you want dig and NS lookup, just install bind tools and you're done. Okay, what happened on the storage side of operating system? ZFS was originally written by Sun. Sun was taken over by Oracle. Sun was very nice to open source all their code. Oracle appears less nice at the moment. At least they are not open sourcing their developments on ZFS. And a lot of people have put their efforts together to set up a new code base for both the Solaris code under which ZFS was developed and for ZFS itself. The project is called Illumos and is working very closely together with the FreeBSD project and some other projects that use CFS. And the FreeBSD project has rebased its sources. We are not deriving from the old Sun repositories anymore. We are now derived from the Illumos code. And we are slowly getting in the new features that are developed in the Illumos project now. One of the things that changed when CFS went over to Illumos, people who have worked with CFS know that both your pool and your file systems have a version stamp on it. Newer kernels can still access older file systems, but you have to upgrade them to a newer version if you want to make use of newer features. That was a linear range of numbers, 1, 2, 3, 4 and up to 28 for the pool and up to 4 I believe for the file system. With multiple projects working on ZFS simultaneously, it was very difficult to define which are the features in the next version and which features come afterwards. They compete and want their features in before the other ones. So instead now we have feature flags, and that's indicated by version number 5000. So if you see ZFS pool with version 5000, you know it's handling features, which means that every single feature has its own flag, and you can have various combinations of features available depending on which code you're using. So it's easier to maintain in the future. We got L2R compression. We got that is a big problem. You see my mistake? Where have I been? We have CFS support now in BSD install, of course, not in sysinstall. So BSD install can now install your root partition on a ZFS pool. It can even install it on a ZFS pool on top of a Jelly and Crypto device. So we have got a lot of progress there, and all the people who have complained in the past that it was so very difficult to install your FreeBSD on something different from just a plain UFS on a MBR partition disk. Play with BSD install and you'll see the world of ZFS opens for you. Right, we've got kernel-based iSCSI support now. Until now we only had iSCSI as a userland utility. People have been using GrowFS for UFS. Well, we can now do that on a live file system. You don't have to unmount it anymore. And we also have an implementation of Fuse in the base system. Fuse allows you, if you don't know, to run a file system code in user space instead of in the kernel, which is very handy for development, but also if you want to import file systems from other operating systems and don't have the resources to build it into your kernel. Well, some random changes in the end. Almost last slide, I think. We used to support 1 terabyte of memory. Your company has been building a nice machine for the FreeBSD Foundation that has a little bit more, I think. The project got their act together and we now support a full terabyte address space instead of just 1. Debugger enhancements, we have got bmake from NetBSD. I don't know exactly the benefits over our previous one because we didn't use GNU-make for a long time already, but it seems to be better. Capsicum, it's a framework in which you can sandbox applications within the application itself. So for instance, you can start up a Capsicum enabled browser, and while starting it you can disable the feature to write to certain parts of your file system, or you can limit your writes to only 1 configuration directory. So it will hopefully greatly help us in the future to further cut down on security attacks, applications, reading our stuff and changing our stuff on our disk. With the world of video controllers being reduced to 2 or 3 players now, NVIDIA, the Radeon line of AMD and the built-in controllers of Intel. We had binary support for NVIDIA. Radeon was lagging behind. It's now being upgraded and we can support video controllers up to the 86,000 chipsets, and some of the support for 87,000 is already there. USB audio has been upgraded. New command FreeBSD version. Very simple little thing, but it's very useful. How you know what version of FreeBSD you're running on a pre-FreeBSD 10 system? Anyone? What does uname tell you? It tells you the string which was put in the kernel at compile time. That should tell you the version of your kernel. It doesn't tell you what kernel is in /boot/kernel at the moment. It tells you the kernel that's running. So if you've just upgraded but not just rebooted your system, you see the old one. But how do you know if your userland is already up to patch level 4 or 5 if some security fixes have been put into SSH or SSL or whatever? We didn't have anything there. So now we have FreeBSD version that try to find out as well as possible at which version of a release or security branch we actually are. UTMP used to be the little database that holds the records of all the users that are logged into the system. Written at the time of Bell Labs Unix, with fixed size fields for the name of your terminal and for your username and all that kind of stuff. So if you log in over your network, if you're lucky, you can see that you're logged in from your IP address, but often it's cut off because it just doesn't fit. UTPX is a much more flexible database that has enough space for whatever location you're logging in from to be stored. And we now finally also have longer usernames. So, well, this one is 31 characters. We can go up to 32 now. You can see the usefulness of that. And well, that concludes the what's new in FreeBSD 10. I have left out obviously many of the smaller details, the individual command line flags and stuff like that. There's just not enough time to tell that in 45 minutes and it would be very boring. We have the release notes. You can find them on the FreeBSD website, of course, as usual. So I'd like to thank all the people who made it possible for me to stand here and tell you about this. And all of you, because standing in front of an empty room is no fun. I've got some references. I'll put this slide up back after the last one, where you can find your stuff, of course, the website, but also the FreeBSD announced mailing list. If you're not subscribed, please do. It's a very low volume mailing list, but at least you know when new releases come out and when imported security fixes are around. If you want to read more, look up the other FreeBSD mailing list. There are dozens of them, and depending on your needs you can find most of the information of what's going on. And I think very worthwhile to read are the FreeBSD status reports. They should come out roughly once every quarter. and they give a summary of all the development that has been going on, but also the project work that has been going on. So, ask me to ask you, do you have any questions? Yeah. Sorry, is there any? Yeah. So the question is if there's any performance impact if you move from GCC to Clang. There is not one answer that answers all the cases. I'm afraid Ed is not in the room. He's the guy who did a lot of the work. But I think that at the moment Clang produces code which compares quite well to GCC on the performance side. I know of one functionality which is missing, which is embedded functions, but I think mostly Clang can now do what we used to do with GCC before that. There are some ports that use features of the newest versions of GCC, so if you want to install those ports, they also pull in the latest version of GCC as a port. Not all of them are yet available using Clang. At least the whole base operating system can be compiled now, userland and kernel. And as far as I know, the performance is comparable at least to GCC. Okay. So for the recording, the answer from the room is that on the FreeBSD build cluster, where all the ports are regularly built, compile time is roughly the same to build all your ports using Clang as what we used to see when building with GCC. That's correct? Yeah, thank you. Other questions in the back? Does the new hypervisor support only Intel CPUs or does it also support new AMD CPUs? When I did my last talk on Beehive, that was a couple of months ago, they were working on AMD support. I do not have AMD machines myself, so I've never tried to do that. But either it's there now or at least it's coming quite soon. More interestingly, I would have expected the question, does it also support other architectures, like ARM? Currently, no. But it's on the wish list, and people are looking into that. For specifically the ARM64, that will come soon. Right. I think that we're going to that I'm going to be kicked out. Only one question that I missed from the room. Think about that when you go home. So for those who want the references. Lenny, thank you for giving me the opportunity to stand here and talk to people.